Come on.
Welcome to the Joy of Coding.
Hello, and welcome to episode 178 of The Joy of Coding. My name is Mike Conley. Gonna be digging into some Firefox stuff as per usual. Gonna be looking at a test failure. That's gonna be fun. Mysterious test failure that I don't fully understand. So we're gonna dig into that today, and we'll see how it goes. Let me share my screen. And actually, the first thing I want to do, as per usual, is show the agenda. Today is May 15th, 2019, episode 178. A reminder, as usual, no plan survives breakfast. I think I know what I want to do today. I have a sense of the things I want to try and tackle, but it might go wrong. I might get stuck. I might get sidetracked. I might go down a rabbit hole. We might fix it. We might figure it out. Anything could happen. It's the joy of coding where none of this is pre-planned. I'm really just kind of going off the cuff here and really trying to capture software development in the raw. The other thing I want to point out is that you have access to this agenda that we're looking at. If you're watching this on YouTube, check out the video description, which is over down here. It's down here. If you're on Air Mozilla, check out the handouts section over here for the agenda link. And if you're watching this on Twitch, then I'm about to drop the link into the Twitch chat in 3, 2, 1. Booyah, there it is. Although there's a little bit of a delay, so you probably saw it show up in the Twitch chat, and now you're hearing me talk about it because that's how delays work. All right. I'm going to skip over the episode guide because I really want to get into it, but suffice to say that there is an episode guide and you should check it out, and thanks goes out to SmurfD, who does so much to help keep that episode guide going and running. And please send pull requests and send your own notes if you want to contribute to the episode guide. If you want to hear longer preambles, watch a previous episode. I tend to talk about the episode guide in other episodes, but I really want to get down to work today, so let's do it. Well, what am I working on today? Well, let me find a good terminal. This is the one I want to work in. So let me zoom in. Let me resize the window and clear. So I've got, I think we were working maybe on this last week. Let me just check to see what we did last week. Live coding during last week's episode. What did we do? I didn't write anything down. Now let's check the episode guide. We can figure out what I did last week. Actually, episode 177 is not in there, but there is a pull request for it from SmurfD, and we can take a quick look and see what he wrote. So I worked on making the tab crash. I talked about making tab crashed work with Fission. I talked about making browser child ready for Fission. I talked about on before unload. Okay, good. So I did cover a lot of what we're going to be working on today, because effectively I'm hoping to keep working on this browser child thing from last week, bug 1533949. Let me get a link to that in the doc here. Make browser child ready for Fission, and then it's this bug number. And I'll hook it up to the actual bug. This is what we're working on today. And I've actually got most of it done. If you take a look at the bug itself, I'm going to save that. And then if you reload the agenda, you can check out the bug. And I'm going to hide my notifications from here on out. Hold up. 1 sec. I just don't want to get interrupted by notifications. Nothing. No notifications. Okay. So if you take a look at this patch, I actually already have a chunk of the work done. I think we talked a little about it last week. I put in a giant comment in here kind of talking about the sort of thing we were talking about last week. Process contiguous subtrees is, I think, what I eventually locked onto as like a terminology for that concept we were talking about last week. And I've got a nice chunk of documentation in here to kind of explain it. And I've got this thing more or less written, and it works. I pushed to try and a good chunk of tests came back green, but some came back orange, and I want to figure out why. So one of the tests that came back orange was this one. Which one have I been running it in? This one. This test right here. So I'm going to actually go back to my other terminal, which has a bigger font, and I'll show you what happens. Well, first of all, before I do that, let's take a look at the working directory, working state, see if I have any changes that are worth mentioning. Yeah, that's me logging something with a big old swear there. Sorry about that. Maybe I should hide that. Maybe I should put that away. Let's put that away. The reason this test fails is because, well, I've got part of the puzzle solved. And part of the puzzle is that we have this event that fires, DOM window close, anytime the window.close API is used. That is only paid attention to for windows that have been opened with window.open. So only windows that have been opened via JavaScript can be closed using window.close, either externally or to something that has a reference to the window, or within the window itself, it can call like .close on its own window object and close itself. And whenever that occurs, this DOM window close event is fired, and that's what we use to actually close the window. We respond to that event and we close the window, or we close the tab, because sometimes we've got a tab and not a window, so we close the whole tab as opposed to the entire window. And in the case of about add-ons, which loads in the parent process, we actually don't want to do what we're doing here. So if I look inside browser element parent, where I was capturing the DOM window close, browser element child is what I want. Let me put those together here. I was listening for that event, and then I was sending a message to the parent process saying, hey, we got a close event. We should do something about it. So we send an async message to the parent, and then the parent over here responds to that DOM window close message. And what I did was I made sure that it's the top level browsing context, because we don't pay attention to that event whenever it comes from like a subframe. And then what did I get? Oh, I found the browser that it's associated with. And then I dispatched the DOM window close event on the browser element itself. And the reason for that is because there's an event handler here that is listening for the DOM window close event, and it does the work of either closing the entire window if there's only one tab, or finding the associated tab to the browser and removing that tab. And that's great. This works for both E10S and non-E10S now, because the browser element parent is dispatching the event that the non-E10S mode expects. Now the difference I made is that before I was, this is what I was doing before and the test was failing. So let's see what that looks like. Right, I need that. This is what happens when I run it just as it is pushed to Fabricator. And there's a test failure. And that test failure is because of an ordering issue. The ordering issue seems to be that, like, what this test does is it tests the new about add-ons page that's being worked on that also loads in the parent process. And the way old about add-ons and new about add-ons is supposed to work is that whenever you like remove add-ons from the list here, when you click remove, it doesn't actually remove the entry from the list. It just puts them into a removed state. So for example, let me find an old add-on here, like brief. I'm gonna remove that one. It keeps the entry in the list so that you can undo it. But if I remove it and then I close the add-on manager and then reopen the add-on manager, now brief is gone. So by closing the add-on manager, something was committed. Like we expressed an intent to remove an add-on, and then by closing the add-ons manager, that's like, okay, it's actually being removed. I've lost the ability to undo at that point. That's the expected behavior. And this test parts of that, except that it's testing the HTML version of about add-ons, which is underway, which is being worked on. But the concept's the same. The problem appears to be that there's an ordering issue. Specifically, it's like, I think the problem is that there are two DOM window close events happening. Like we have a browser element child that works for both. It works for both in process, parent process pages and content process pages, and it's capturing that event and then sending a message to the parent to fire that event up here. And so for in process content like about add-ons, that event will get fired twice. Once whenever the tab itself, like whenever the close event is fired normally, and then another one because like the browser element child captures that event, messages to the parent, which we're already in the parent process at that point. We're not in a content process, and then it fires it again. So I added this condition. I said, well, let's avoid firing that event if the browser is a remote browser. If we're running out of an out of process browser, that makes sense. But then here's what happens, and this is what I'm hoping we can investigate today. When I run the test with that change, this is what happens. Sorry, running the test. The whole window closes, and then the test does not run. The test halts there because the whole window closed. And I don't know why that's happening, and that's what I want to investigate today. So I've done a little bit of investigation already, and part of the issue is in how the test closes or completes itself. So the test that I'm running is this very complicated test here. This one right here. And it's at this point, right here, where the window is closed in await close view. And so at this point, we close the tab, or we're expecting to close the tab. Now it's passing a win, but if we look at win, what win is, I believe win is, let me just double check, load initial view. It's the content window for about add-ons, right? Which makes sense in something that loads in the parent process. You can get access to the content window. And by content window, I mean about add-ons is notion of window. So whenever it's outer window. This terminology is pretty bad, but that's what's going on there. These are all confusing me. I'm going to put that there. I'm going to put that there, and I'm going to close all of this other stuff. Let's close all of this other stuff too. Okay. So win refers to the content window, and then whenever we say close view, we're actually asking the content window, the about add-ons content window, to close. Not the entire browser window, but just the about add-ons content window. And that happens, here in close manager. Close view is called, and that just passes close manager, or it passes it to close manager. And what it does is it calls .close on the window itself. Now what's interesting, I just noticed, is that there's something called manager window, and I don't know what that is. Manager window. Let's take a look at what manager window is. Manager window is open manager. manager window, so it's passed to the callback. What? Open manager, pass null. Okay, null. There's no callback. But you return a promise. And the promise, was the promise resolve with the manager window? The manager window is what? Something called, that's passed to setup manager. Setup manager is passed to subject. That is an observer for a topic, a particular topic, for EM loaded. So what is that? What is the subject for EM loaded? Oh, that's for Android. Subject. That's another add observer. Notify observer. Here we go. Window. What is window in this case? So whenever extensions loads, excuse me. Excuse me. What is window? Window. Well, window is probably, in this case, window, because extensions.js is loaded inside of the extensions, like the About Add-ons tab. Window is just the outer window again. So, okay, manager window is the same as win, I think. I don't know what win equals browser.content window. These should be equivalent. I don't know why they might be different. But let's double check. That's an assumption. And I wanted to double check that. First, I'm going to blow my nose. Something in this room's bugging me. Pardon me. Let me just do this out of frame so you don't have to watch me. Pardon me. Smurf notes that I didn't have any links to notes in previous episodes. Evernote note. That's true. My bad. I did a poor job with the last episode's notes. I don't think I filled them out. So what I'm going to do is I'm going to add a debugger statement right here. And I'm going to run this test again with the JS debugger. What? Debugger. Oh, hang on, I have to go Moki test whenever I run with JS debugger. So strange. Okay, so we've got our we're in our breakpoint here. Let's take a look. What is win? That's the About Add-ons outer window. And then what's win.manager window? Oh. So there's like an inner window and an outer window. I guess there's like win.outer window root. It's the owner global. It's the Chrome window. And then win.manager window dot document. It's a Zool document about add-ons, and inside it there's actually something else. So maybe I need to understand the layout of what's going on here. Like, window. Oh, I've got the wrong window selected here. About add-ons. And what just happened? The window closed. Huh. I think my breakpoint detached. But let's see if I can figure out how to get the new about add-ons working. The HTML about add-ons. Presumably there's something here in head, like a pref. HTML. HTML. Well, this kind of makes sense. HTML view browser. Browsers. HTML view browser. So I see. HTML view browser. If get HTML browser. HTML view. Use HTML views. Okay, so there is a pref here. Extensions HTML about add-ons disabled or enabled. So if I like flip that pref, so I think this is now written in HTML, this right here. And now let's take a quick peek. Yeah, this looks like it's all HTML here. And then there's a browser element. So this is, I think, window. And then I think this is like the outer window is manager window. Okay, I understand. I understand. So one's kind of embedded in the other. It's a bit strange. But okay, I get it. So going back to our test, when we say close view, what we do is we say close, and then we pass in the outer window, the manager window, and we call .close on it, which makes sense. And then we resolve this promise whenever the unload event handler fires. And it's when the unload event handler fires where like we have like all these, I think about add-ons is not, it's using web components, and there's like a disconnect callback when those components are removed from the DOM. That's when the actual, that's when the point occurs where we like actually uninstall the add-ons, is whenever the disconnection occurs from the DOM because the window went away. Okay. So how come the change I made here is causing the entire window to close? For example, if I go to this add-ons manager and I go window.close now, it doesn't close the entire window, it just closes the tab, which is what we would expect. Now if I were to do that in a build with my patch here, let's see what happens. Oh, that's the old about add-ons. Hold on. I need add-on. What is the pref called? HTML about add-ons. Okay. Oh, I gotta like reload now for it to take effect. Okay. About add-ons. What? Is this the I guess I don't have any add-ons in this profile. Let me just check to see if this is like the HTML version. Looks like it. I think. Browser, HTML view browser. Yep. Okay. Now let me try and call from here, window.close. Window.close. So it just closes the tab as you would expect. That's what I would have expected. That's great. How about if I call it from within the subframe, which I wouldn't expect that to do anything. Window.close. Ignored. Good. If I call it from add-ons again, window.close, closes the tab and not the window. And we shouldn't be going through this code path. I'm expecting that if I were to open the browser toolbox, that the actual closing of the tab is happening here, where we remove the tab right here. So let's double check that. Add-ons. I'm going to say window.close. Wait. Yep, window.close. Interestingly, that's not where it happened. Let's see where it happens. Remove tab. How do I find here? Tab browser. What? I think the debugger's a little messed up. Tab browser.js. There we go. Remove tab. So something is removing a tab. Let's find out what it is. How come I can't set breakpoints on this condition? All right, let's do it there. About add-ons, window.close. Okay, we have our breakpoint. We've hit it here. Let's see what the stack is. Apparently on line 4543. What? That doesn't make any sense. This is all wrong. I don't trust the debugger. I think this is nonsense. This line is definitely not called. So yeah, we cannot trust the debugger. That's the problem with working in nightly mode on the nightly browser. So let's go back to first principles with printf debugging. Dump removing tab. All this like DevTools stuff. I can't tell if what I expected to happen happened. So I don't actually see the handler through exceptions. Doc shell is null. There's this big old stack that I don't understand. Okay, so I'm not seeing removing tab being logged, which is really interesting. This is another way of getting a stack when your debugger is failing you. Huh. What? So maybe I need to build? Maybe the reason that I'm not seeing the logging is because I need to build? What happened to my symlinks? Shouldn't need to rebuild. Okris asks, when I have a pip window open, that's a picture-in-picture window open, and I click on a link in a tab, which is the source of the pip window, will it close the pip window? And the answer to that question is, the picture-in-picture window will stick around until one of two things. One, you close it yourself. Two, the document that is the source of the video that's being showed in picture-in-picture goes away. So if you were to navigate away and that caused the document to unload, yes, the picture-in-picture window will go away. If you also close the tab where the document's hosted, or the window where the tab's hosted, or the window where the document's hosted, then the picture-in-picture window will go away. No problem. Okay, let's open up a tab, add-ons, window.close. How is this happening? So the tab's getting removed, but like nothing's getting dumped to the console. Like all of these dev tools things are getting dumped to the console. Oh, you know what? The whole window's closing. Have you noticed that? Maybe I just failed to notice that, but like window.close. Yeah, the whole window's closing. So the bug is occurring. The bug is occurring. So let's now see if what's happening is that we are just straight up closing the window. So that's good. We've reproduced the bug from the test. This is the part that actually closes the window. Closing the window now. Race content. Close. That's so strange. Now, what if I were to make it so that we don't dispatch this? Or we do dispatch it if you're a remote browser or a non-remote browser. Which is weird because this shouldn't make any difference because, or if anything, this should make it worse. Because now we're going to dispatch two events. Two DOM window close events, but so now the tab closes. Why is that? And because remove tab is called. When we handle that event, is something special occurring? Like, what if we put this back, but we don't actually send a message? That will make the code that I've got running in the parent inert, so nothing happens. We're going to gather information. We're experimenting. Whole window closes. Whole window closes. Maybe I need to know more about this DOM window close event. DOM window close event. No documentation. Thinking. How come actually dispatching a DOM window close event in the parent process again causes us to not close the whole window and rather close the tab? And it's not even that we're entering this. We don't even enter this part. It's like something else takes over to close the tab. That's what we need to understand. The part that's closing the window. Let's take a look at how this DOM window close event is dispatched. Let's look at how it works. Blah, blah, blah. Where is it dispatched? Here. Someone chose to prevent the default action for this event. If so, let's not close the window after all. That's what occurs if dispatch custom event returns decides to prevent the default action. Otherwise, we do final close. M is in close. Was in close. M in close. Where's M in close? If we force close, here's where we dispatch custom event that we are forcing close. Final close. Is closed is true. And then we post a close event for final close. So let's do a fun thing. Let's do this thing where we run our test, which closes the window. Let's do that. And make sure that that still occurs. Yep, whole window goes away. Now what we're going to do is we're going to run it again, but I'm going to say no auto run, so that the test does not actually run until I say I want it to run. And I'm going to open up another terminal window. I'm going to pump up the font, pump up it up. And then the process for the parent is 49137. I'm going to spawn LLDB. That's my debugger. For some reason, I get this weird error. I'm going to attach to 49137 the parent process. I'm going to see if I can get like a breakpoint attached to final close and force close and close outer. Okay, and we'll see which one we hit. Okay, we hit close outer. If we look at the trace, close outer, and then we see some JavaScript on the stack. So if we call dump JS stack, we can dump the JavaScript, and it's because of the actual test here at line 430 from head that's calling the dot close. So we actually get the call to close outer. Makes sense. And then what happens? Do we have a pending close? If we're not in a close or can't close, we say we are in a close right now. We dispatch DOM window close. And then we final close. And final close, I think, is what actually closes the window. Oh, now we have a pending close because we have posted the close event. Okay, and so the window is finally going to close. Right, and then the window goes away. Okay, now let's look at the other case. Detach. We're gonna go back to what we did before, but we're gonna put this back. We're gonna see what the difference is. How come this one closes the tab and not the whole window? Smurfy's like, unrelated question. What's the specs of your Mac? MacBook Pro, right? Hard drive and memory. This is a MacBook Pro from 2015, I think. I need to upgrade from High Sierra to Mojave at some point, but these are my specs. 16 gigs of RAM. It's 2.8 gigahertz Intel Core i7. It's from the mid 2015s, so I need an upgrade soon. This thing's almost 4 years old. Wow, that's actually pretty long in the tooth. Okay, so let's do our experiment again. And now I'm going to attach to 49931. And the same breakpoints should still be there. And what happens? We got close outer. Say we're in close. We see if we're dispatching on window close. And we go into final close. Have pending close is true too. Okay, so then we have this thing. So an event, a close event, was put on the queue. Final close. Post close event. It's gonna run this close event. And it's gonna call really close window. So that's what I should set a breakpoint on next. Break. NS global window editor. Really close window. Okay, so there we go. Get the window tree owner. And then we bail out pretty quickly. Really close window. If there's no tree owner when the window is already closed, but if we're a browser window, it could be in some nasty self-destruct cascade, which mostly ignore. Continue. And now we get close outer. So it's like a close, the first close kind of got ignored. And now the second close is the one that's going to actually close the tab. Whoa, we're getting like a bunch of close events. Where are all these close events coming from? Close. Because we must call dump JS stack. It's the same close manager. We're getting all of these different close events firing. What's happening? Manage your themes. So the themes thing. Close, close. Close, close, really close. Will this ever close? Not really. Like, detach breakpoints, like detach. And then the tab goes away. Oh, you know what? It's because what was going on were different tests were running. That's what was happening. I need to actually disable a bunch of these other tests. I think that'll probably help avoid confusion. So only run this first test. I'm going to skip all these other ones. So that's going to help me avoid confusion. I was like, why are we running all these close events? So we're going to skip this one, this one, this one, this one, this one, this one, and this one. Although now that I think about it, none of these other tests run. I don't think there's any setup. But I could have just used only to run this one. But whatever. I've already done the work. Okay, so how come that close event doesn't actually cause a close to occur? I didn't actually answer that question. Whoops, why did I exit? Why did I exit? So let's try that again. And this time I want to understand more about, and I don't want to, I want to be able to see each step, each thing that is painted. So I'm actually going to put this over here. I'm going to shrink the font down a little bit. I know it's a little harder to read, but I want to have the window on screen. So we're going to attach to, what's the process number, 50118. And then the function was called really close window. Okay. Now the window I want is this one. So if I remember correctly, there should be some JS on the stack. Oh no, there's no JS on the stack. We've exited. We put this close event on the event loop, and the JS came off the stack. And now we're running this close event, so we're really closing the window. And we're saying get the tree owner window, clean up. Then what happens next? Why? Removing the tab so that the other tab close event is fired. Why is the first one ignored? What causes the actual window to close? That's what I want to know. So let me see what code do we run when we actually close the Zool window? Chrome win, bwin is tab content window. Destroy, but not if this DOM window belongs to a tab browser doesn't correspond to tab. This allows a well-behaved tab to destroy the container. Tree owner as win destroy. If root win is this, and we're not a browser window, or we're not a browser window, or this is a tab, then we do this. Destroy the entire window. Not if this DOM window corresponds to a tab browser and doesn't correspond to a tab. Well, in this case, the browser doesn't correspond to a tab. Normally we destroy the entire window, but not if this DOM window belongs to a tab browser and doesn't correspond to a tab. This allows a well-behaved tab to destroy the container as it should, but is a final measure to prevent an errant tab from doing so when it should. This works because we reach the code when we shouldn't, only in the particular circumstance that we belong to a tab that has just been closed, therefore already missing from the list of browsers. It has an unload handler that closes the window. What? What does that mean? And then tree owner as win, destroy. Doc shell, Chrome tree owner. Zool window, destroy. Zool window, destroy. This is where we actually close the window, I think. Okay. So, for some reason, we don't go into Zool window destroy. Let's confirm that by detaching. We're going to run this again, and we're going to make sure that we don't get into Zool window destroy. Zool window destroy. Attach. Okay. Continue. Run. Oh, that's really close window. We don't care about that. And then the test enters, and then we do really close the window again, and then we do probably do Zool window destroy whenever the test finally finishes, which makes sense. Okay, cool. Now let's do that again. So what we learned from that is that Zool window destroy is not called whenever we attempt to close the tab. That makes sense. Now let's put these things back so that we're in the case now where the window does actually close and see what's calling Zool window destroy. Get ourselves a backtrace. SmurfD is like, BZ has written something now when we have something something. Is this needed? Yeah, I see that periodically where it's like there are old notes about like ways we can maybe improve the code. I don't think that's related, but I think that's more just like idle or redundancy that we might not need in the code that BZ is wondering about, I think. Okay, really close window. Okay, Zool window destroy has been entered. Let's find our backtrace, and then let's write this down. Alright, let's put that here inside of this note. It's no longer blocked. Okay. We decide to really close the window, and then we say web shell window destroy. And then that causes the Zool window to be destroyed. So on line 6292 of NS Global window outer. Line 6292 here, we say destroy the window. That calls NS web shell window destroy. So here's my hypothesis. For some reason, we are hitting this in the bad case, and for some reason, we are avoiding this in the good case. How do I figure that out? Well, let's use the debugger. Detach. We're going to close. So let's see if we get to. Let's see what happens inside really close window in the case where the tab only goes away. What? Oh boy. Here we go. That's what we want. Someone made a really good joke in the channel. They're like, is this what they mean by closed source programming? Or is this what closed source is? Smurf D. Clever wordplay. I like it. Attach. Okay, so we want to add a breakpoint for, what was it? NS web shell window destroy. Or really close window and NS web shell window destroy. I don't think we're going to enter this one. And I think we already have a breakpoint on this one. But we added another one anyways. Really close window. Tree owner as win, and then we bail out. P tree owner as win. Couldn't materialize. It's been optimized out. Doesn't make sense. I could understand it if like we're causing the close to occur by causing double the events to fire, but we're causing the by only having one event to fire. That's when we're closing the window, which doesn't make any sense to me. Detach. Detach. Tree owner as win. So how does this work? We're closing the window. If there's a browser DOM, we're gonna get a reference to a browser DOM window, the root tree item. We're gonna get our doc shell, get the root tree item, and we're gonna get the root window, and we're gonna see if we're a Chrome window, browser window, if there's a root window. Is tab content window. But if we're a browser window, we could be in some nasty self-destroying cascade that we should mostly ignore. If there's no tree owner as win, this window must already be closed. Must already be closed. Hmm. Well, let's confirm that observation. 6292. Hopefully this won't take too long to build. Or running tree owner as win. We have owner as win. Else printf no tree owner as win. And then there's this other thing. Printf we have a root win. And we have a doc shell. Else printf didn't succeed in running tree tree owner as when destroy. And then down here, no root win. And down here, no doc shell. What we're doing here is some classic printf debugging, which there's nothing wrong with that. Whatever gets the job done. Root to do. Someone's asking me a question. I'm just going to answer it real quick. Try this. Okay. So what are we running in, like what configuration are we running in first? This is the good case. The good case where only the tab closes and not the window. But the test also just like fails. Telling manager to close. It's like do we even enter? I don't even know if we enter here. Printf. Entered as global window outer really close window. This doesn't make sense. What's going on? Welcome to my life, where things don't make sense and the points don't matter. Let's try this again. I shouldn't have put that no auto run in there. I do want it to auto run. Telling manager window to close. We never enter, like we do at the very end here, but we never enter the close thing. Really close window. That's very interesting because it's counter to what we observed in the debugger. Let's do more. Final close. Close. Bailing out. Running final close. Okra says, pip works great on Linux so far, though it would be awesome if it had volume control, since at the minute it's only in the video tab. Yeah, I mean, the fact that it works on Linux is a real accident, because I've only been focusing on Windows for now. Let's see. Let's run now like this. I'm just going to remind myself. Okay. Moving tab. So running final close, global window, final close is called. Final close happens. And if posting close event, trying to post close event. I failed to post and it's close event, really closing window now. Else successfully posted as close event. And then post close event. Running post close event again. Running a really close window. And I don't think we'll get that far because okay, let us run this. Tab goes away. What goes on? So we post the close event, but then the close event, the NS close event doesn't actually run. Running NS close event. We have a window. Done running NS close event. Learning a lot about window closing. What a pain. That's what I'm learning. Beep, beep, beep. Beep, boop, 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 boop. Okay. Successfully posted the close event. Then the close event, then it runs it down here. And then at that point, there's no tree owner. Because the tab's already been removed. Okay, so theory. Theory for why this is happening. Theory. Upon calling window.close, a DOM window close event is fired, and an NS close event is also fired. In that order. In the single process case, because about add-ons is because about add-ons runs in the parent process, DOM window close is responded to first. Let me look at more detail into what used to happen with DOM window close. With the old one. We ignored it if it wasn't trusted. We added a window close here. We did it in the capture phase. Tab, and then we prevented the default on the event. I think this is where things break down. I think I was supposed to prevent default on it. That's what we used to do. Okay, so theory. Upon calling window close, that happens. Because add-ons runs the pair process, DOM window close is responded to first. We used to prevent default on the browser. Get tab for browser. And we get the target doc-shell Chrome event handler. Right. Okay. We used to prevent default on the browser. Prevent default on the DOM window close event and close the tab in the event that the browser was a child of the browser, of the tab browser, or the tab's browser itself. I know it's a bit funny way of saying that, but because in about add-ons we have like the top level browser and then we have this like smaller browser inside it for the HTML stuff, which is nuts, but that's the way it works. And I think that's the problem. So we used to prevent default, we don't anymore. In the case, whenever we dispatch, when we dispatch the DOM window close event to the parent to close the tab in the single process case, what do we do? Close the tab in the single process case. When we dispatch the DOM window close to the parent to close the tab in the single process case, we end up running that first and removing the tab so that by the time the NS close event fires, there's no longer a tree owner, and so the test passes. When we don't dispatch the DOM window close event in the parent the NSClose event is allowed to run because the DOM window close event is not prevent defaulted. It's not prevent defaulted in for either, but by the time it runs, the tree owner is gone. The close event is allowed to run, and that NSClose event decides to destroy the window. Okay. So I poorly dealt with, like, I have this old code here that is expressly designed to work with yeah, Chrome event handler dog shell target browser target dog shell Chrome event handler. Okay, so browser element child, when it sends up this DOM window close, sends it up to here, gets the embedder element. If not browser.isRemote browser, we're going to say that browser equals that. No, wait, hold on. I don't want to do that. Tab browser, this DOM window close event needs to be modified. It's event.target. If not browser.isRemote browser, browser equals browser dot here dot target. No, that's a lame way of doing it. Yeah, okay. To do explain. And then we do want to prevent the default. If DOM window close. That's probably okay to do that secondary close there. Okay, so let's run that. Browser base content. Yay, the tab didn't close. And the test pass. Hey, all right. Hey, so that's exactly what we needed to do. Now let's turn all the tests back on. Skip and make sure they all pass. And then if we've got a couple minutes at the end, we'll clean up the patch, and then maybe we can explain in that little explain zone what we need, what we're doing there. So the problem was that we weren't handling the case where there is an in-process browser, like a parent process browser, that is not necessarily a browser tab. We were not handling that case. Because in the case of the About Add-ons viewer, there's a sub-browser of the browser. Browser, all the way down. Akris asks, can you confirm that resizing the pip window should also resize the video vertically, so there shouldn't be any gaps between video and the top and bottom window borders? On Windows, we have something, like, I'm assuming you're a Linux user, so right now there is no support for picture-in-picture on Linux. If it's working even somewhat, it's by accident. On Windows, we have the ability to lock the aspect ratio. So on Windows, it is expected that the pip window, the picture-in-picture window, will have its aspect ratio locked, so that by resizing one side, we'll resize the other side to maintain the aspect ratio of the video. But if it's working at all on Linux, completely by accident. Yay. What the? I thought I got rid of those log messages. Oh, I didn't actually. I did not actually get rid of the log messages, but I need to do that now. In NS Global window. Window outer. Get rid of tab browsers. Where is it? Remove tab. What line is that? It's near line 2788. 2788. All right, we're going to get rid of that. Okay, so let's add some commentary here. If this is a non-remote browser, the DOM window close event will be dispatched to the parent process. Will bubble up naturally and doesn't need to be redispatched. Tab browser. I do this. First little check here. That browser is event.target. If browser is not a remote browser, if not event.isTrusted, return. Otherwise explode. It's possible that the browser that fired DOM window close in the single parent process browser case, it's possible that the browser that fired DOM window close is actually a child of another browser. We want to find the topmost browser to determine whether or not this is a tab or not. This is for a tab or not. The Chrome event handler will be the topmost browser. So, Pramila, so is tab, so we don't need to do it again. In the parent process browser case, NSClose window, or NSClose the NSClose event will actually take care of tearing down the window, but doing so in either but we need to do this ourselves in the content process browser case. Doing so in both cases doesn't appear to hurt. Okay. If not, so we're going to move. We're going to do that. Since if we don't prevent default on the DOM window close event, then we risk then in the in process parent process browser case, we're telling the platform to close the entire window. Calling prevent default is our way of saying we took care of it. Took care of this close request by closing the tab. Okay. So that, I think, will do it. Let's run those tests one more time. Let's just do a full mock build. We'll run the test one more time. Akra says, okay, so the ratio is also locked on Linux, but it makes gap between video and window frame. Doesn't look good. When we start supporting Linux, we'll look into it. But for now, not on the radar. Windows is the only one we're targeting right now. And the fact that it's working on Linux is kind of a miracle. It's completely unexpected. It's possible that I wonder if there have been people who have landed like patches for the GTK support. Let's see, lock aspect ratio, mlock aspect ratio, Zool win lock aspect ratio, and window lock aspect ratio. I don't see any GTK specific code for locking the aspect ratio, so if it's working, that's incredible and not what I would have expected. Okay, running the tests finally. Yay, all tests pass. I'm very happy. Let's commit amend, and we're gonna call it a day. That was a great way to end an episode, with like a success story. I'm actually gonna add another comment up here. And the single process, if the browser is not remote, then we expect the event to be trusted. In the remote case, the DOM window close event is captured in content. A message is sent parent, and the event DOM window and another DOM window close event is redispatched on the actual browser node. In that case, it won't be marked as trusted since it's synthesized by JavaScript. The event won't be. Okay. I think that is a fine addition to this patch. Amend. Now what I'm going to do is push to try. Woof. Why are these all blowing up? I'm going to push to try and make sure that I'm just going to do the Linux debug and Linux opt builds and see if those all pass. And if they do, then we'll do the other builds. Okay. So, let's patch here. Mock, try, chooser, no artifact. SmurfD is saying it's been a while. What, since I fixed a bug? Is that what you're talking about? Oh, SmurfD, you cheeky monkey. Okay, Mocha Test Browser Chrome. We're gonna get rid of Linux 32, 64, and CCuv. We're just gonna do debug. Debug and opt. Linux 64. Might as well do Mac OS as well. And Windows 10. Let's do them all. Windows 10. Not those ones. We'll do debug and opt. We'll avoid ARC64 for now. And shippable. We won't do Windows 7. Okay, push. Let's see if it likes those. And with that, I'm going to call this episode done. Thank you so much for watching episode 178 of The Joy of Coding. I hope that was interesting. It was a bit of a struggle. I didn't think we would actually make any headway, but we had some kind of breakthrough at the end. We were able to make some progress. So now we have a patch with some commentary that kind of explains what went wrong. And yeah, I've pushed it to try, and hopefully I get back some good results. That's it. Thanks for watching. I will talk to you next week, hopefully, with episode 179. So take care of yourselves. I'll see you next week. Take care. Bye-bye. See ya.